Akansha, you're on mute.
Thank you.
No worries.
So, ladies and gentlemen, a very good evening to one and all present here. Hope you all are doing well. I'm Akanksha Rana, your virtual host for today's session. On behalf of HackBMU organizing team, I would like to extend a very warm welcome to all of you to another pre-hackathon speaker session at HackBMU edition 4.0. Elevating the level of a hackathon that has a legacy of providing a welcoming and supportive environment to all participants to develop their skills. This year, by going virtual and utilizing the power of communication technology, HackBMU 4.0 will host a series of workshops and tech talks throughout the month of March and April. Now, these workshops will allow HackBMU participants to gain in depth knowledge about new technologies, technical communities, and more. To know more, visit us at www.hackbmu.tech. Without further ado, let's get started with today's session. Natural language processing is considered a difficult problem in computer science. While humans can easily master language, the ambiguity and imprecise characteristics of the natural languages are what make NLP difficult for machines to implement. Feel like gaining more insight into the basics of NLP? To help you more learn about natural language processing, we have with us our esteemed speaker, Ms. Shambhavi Mishra. Shambhavi is an undergraduate student exploring computer vision and natural language processing. In her research projects at IR Lab, IIT BHU, and SC&SS JNU, she has worked on speech processing and retrieval. Shambhavi has also delivered work on text categorization and topic extraction, while she has worked as data scientist trainee at Precily. Shambhavi is fluent with SOTA in NLP as well as computer vision. Ms. Shambhavi, the virtual stage is all yours.
Thank you so much for a warm introduction. Is my screen visible? Okay. Right.
Yes, now.
So, hi everyone. As Akansha has very kindly introduced me already, I'm Shambhavi. I'm currently working as a data scientist at a startup called Neurosensum, where we are working on deriving text analysis from different languages such as Bahasa and Indonesia, Malay, Thai, and a lot of stuff. So, today we are going to discuss about natural language processing. I'm going to keep the whole talk to a very intuitive level where we are going to discuss about different problems that arise when we are talking about NLP. We'll be dealing with feature extraction, pre-processing, and in the end, I'll be sharing my personal resources with you as well as a 6-week plan that I followed, which helped me in getting successful interviews. So here we go. So today's agenda, we'll be discussing about natural language processing. How does it work? Pre-processing our data, feature extraction, what are the different tasks involved in NLP, and essential skills for a career in NLP. So what is NLP? So as human, when we are talking about artificial intelligence or we are trying to enable the computer to understand all the different data forms that we as a human do understand, such as visual data in the form of images or videos or text data or the data in form of voices, like you're able to hear, understand, and comprehend my speech. We also need to empower our computer systems to understand the speech as well as text. So NLP covers speech and text both. It is used to understand the structure and meaning of human language by analyzing different aspects such as syntax and semantics. So semantics would involve how the different words are gluing up together and thus providing a meaning to a sentence. So I have worked in speech as well as text in my research projects, although in professional domain I am working more on text. So how does it work? In a very, very raw sense, you can understand that if there's a machine learning algorithm, we are supplying it with two inputs, a label and text. This is strictly in case of supervised learning. In unsupervised learning, we just deal with text. But because the the talk is about introduction to NLP, so I'm going to stick through out the talk to supervised methods. So once you have raw text data, you need to pre-process it. Just imagine you have data from Twitter, which has all different kinds of hashtags and emojis, and there's a lot of sarcasm involved. There are images involved, GIFs, and everything. So you need to pre-process the data into structured data which your system would easily understand, rather than the raw data which is suitable for human mind but not so suitable for the computers. So pre-processing will be the first step of our data processing pipeline into NLP. Then we come to feature extraction. So we as humans understand words in their linguistic sense, just picking up the categorical data. But for computer, we need to process the categorical data into vectors of numbers. So we are going to just read a little bit about feature extraction methods in NLP. And then finally you take the label, you take the text, and you train your machine learning algorithm on both of them, and you can perform different kind of tasks, and we are also going to discuss those different kind of tasks further in the talk. So what is pre-processing? First of all, what you need to do is you need to split your input data. Your input data would be in forms of paragraph. You need to split it into sentences, and you need to split it into words. Why do we need to do that? Because for computer, not every word makes sense. There are multiple times punctuations involved which unnecessarily clutter the information. They do not add any value to our information, and thus it would be a good idea to get rid of them initially. So tokenization would be the first step of our data pipeline. What you do in tokenization is you split or segment the sentences into the constituent words. A sentence is, of course, a collection of words, and now we are trying to, like we teach a baby, you input words, you input characters, so you are getting to the root of all the data. Then you need to clean the data. So special characters like hashtags or at the rates or asterisks need to be removed. Why? Because they do not add value. Again, they do not add any kind of content to our system, and there's no particular code that you can decipher out of special characters. Then we need to remove the punctuations, unnecessary punctuations like quotation marks everywhere. Say you have data from a chatbot which is trying to which is trying to interact with a customer, and now when you have that data, you will have unnecessarily used punctuation marks like inverted colons, commas, and exclamation marks, multiple question marks. Whenever we are typing in our lingo, we add multiple exclamation marks or question marks. These all are redundant, so removing them would be a good idea. What are stop words? So in general, when we are initially trying to learn NLP, we just use a NLTK library. We import the already set stop words and we use them. But if you open and check the NLTK stop words library, you can try printing it. You'll find some words like no, nor. In one of my interviews, I was asked if it is a good idea to always use the stop words, and I, like a naive child, said yes, we always use stop words. And then I was asked to print the list of stop words, and I found that there were some content which were actually useful in determining the emotion or in determining the intent of the text. So be careful of what you're using as stop words. You can always extend the stop words. You can Google check. There are multiple ways to include lists to append into that dictionary of stop words. Also, in my experience, what I've found out is stop words are highly domain specific. So I've worked in legal domain and I've worked in patent domain as well. So in both those domains, there were some words which were so redundant for the machine, and yet they influenced the prediction to a very great level. Say, like if we are talking about the legal data, there's a word called like section 40.a, section something, and section keeps on repeating. And when you're performing a text analytics and you do a word cloud, you can use a word cloud to check what is the major word that appears in the text. So if you're making a word cloud of your input data and you see section coming up, or you see a word like appellate is the one who appeals for some kind of an act. So appellate coming up as a major word, it is not actually adding a value to your system. So you can use it to be put into the list of stop words. So then we come to the concept of stemming and lemmatizing. So these were, I was asked for a difference between both of them. So I would like to focus on that. So both the tools actually shorten the words back to their root form. Stemming is a little more aggressive. It cuts off all the kind of prefixes or endings of words based on common ones. Say you're using ending, so it will cut it down to end. It ings would completely be removed. It can sometimes be very helpful in the case of endings. End also does make sense, but imagine uh, using it on because, and it would be trimmed to bec. It doesn't really make sense. So stemming does that. Lemmatizing, on the other hand, it maps common words into one base word. Like end can be a base word. Ends, endings, and all would be then lemmatized to end. So that is the major difference between stemming and lemmatizing. Stemming words do not often make sense as individual words, whereas in lemmatizing, the words individually have a meaning. So yeah, like unlike stemming, it always still returns a proper word that can be found in the dictionary. So this is a sample function that I always use for all my tasks. So I just thought it would be a good idea to include it in the presentation. You take a doc, you split it into tokens, you then remove all the punctuations, then you put the tokens into a list. And if you don't need numbers, like in my case, the data does not necessarily need any kind of numerical data. So I completely remove any numbers. I just took word dot is alpha is for word. If the word is alphabet, you need to include it into the list. And then I set the stop words, and yeah, that is how I approach the problem. So how do you actually get the intuition of what to do with the data? You just look at the raw tokens, and then you can get an idea, such as you can remove punctuation from words like what's, and removing tokens that are just punctuations like connectors. You can also remove tokens that contain numbers, that like I did. You can also remove characters, like you can also remove the tokens that have just one character. This is what I'm doing in the last line over here. Okay, I'm sorry. Yeah, this is what I'm doing here. If the length of the word is greater than one, only then it is to be included in the list of tokens, else it doesn't necessarily have to be included in the list. So yeah, this is all about pre-processing. Now let's switch to a little more complicated part, which is feature extraction. So, as the name say, how do we encode our text data in a way which is ready to be used by ML algorithms? So, you are trying to extract features out of raw text. We as human beings, when we look at text, our eyes scan the important keywords, and then we make senses out of those keywords. But computer doesn't necessarily work like that. A machine would require vectors for pre-processing the input, and you cannot one hot encode all of the text. One hot encoding would be taking a number, taking an alphabet like A, and assigning it a 1 0 based code. So imagine you're assigning such kind of a code to a long text which would be 200 pages. That doesn't really make sense, right? So for text data, we need more efficient feature extraction methodologies. So that is what we are going to discuss in this section. So what is the problem with modeling text? Text data is messy. Why is it messy? Because you do not have a fixed length of input and output, and thus what we need to do is we need to normalize the text. We need to convert it into numbers with fixed length of inputs and outputs. So let's see how it is done. So the most introductory or naive approach was bag of words approach. Why is it called bag of words? Just imagine putting 10 balls in a bag, and then you're picking out balls at random, and there's no order that is being preserved of which ball came into the bag first. So it is similar in this one. You don't have any order that is being preserved. It is just a bag containing lots of words, and there is no semantic sense coming out of the whole structure. What is semantic sense? When you're reading because any information about the order or structure, the information is about the order or the structure of words. This information can only be understood by the order of this whole sentence. If these words are randomly thrown into a bag, you won't be able to understand what exactly is the meaning that is being conveyed by this whole approach. a whole sentence. So what is a bag of word representation? Bag of words is a representation of text that describes the occurrence of words within a document. It involves two things: a vocabulary of known words and a measure of the presence of known words. So why is it called bag of words? Because any information about the order of the structure of word in the document is discarded. The model is only concerned with whether known words occur in the document, and it totally disregards the whole idea of where do they occur in the document. So you can also understand it intuitively like a frequency based approach. You just have to count how many times that one particular word is occurring. Where it is occurring is not important to us. So what is the intuition behind the approach? The intuition is that documents are similar if they have similar content. Further, that from the content alone we can learn something about the meaning of the document. So that is what we are telling ourselves, that if you want to compare two sentences, you just compare if both the sentences contain same words or not. The order doesn't matter. It can be funny in some situations, but this is how it works. So there were two approaches for bag of words approach. One was a count vectorizer, where we are just frequency based approach. We are counting the number of time a particular term is occurring in a text. The second one was TF-IDF, a little more advanced than the naive frequency based word count vectorizer. So what does it actually target? So a problem with scoring word frequency is that highly frequent words start to dominate in the document. That means that they have a larger score, but they might not contain as much informational content with a model as rarer but perhaps domain specific words. Again, we are talking about the domain specific words here, like I earlier shared, for the example of section in a legal text. So it is occurring very frequently, but it does not convey a great amount of information. So one approach is to rescale the frequency of words by how often they appear in all documents, so that the scores for frequent words like the that are all that are also frequent across all documents are penalized. So if there are some words who are appearing too much, you can penalize them. So this approach is called the term frequency inverse document frequency approach. What you do is you count the frequency of the words appearing in a text, and if they are appearing too much, like more than a given threshold, then you start penalizing them. So TF is the term which scores the frequency of the word across the document, and inverse document frequency is the term that kind of penalizes or it notes down how rare that word is across the documents. So the scores are weighing where not all words are equally as important or interesting. So that is how you behave. Like the simple conjunctions and are then penalized because they are appearing too much during the text and do not convey any data. While term frequency counts how many times and is appearing, inverse document frequency counts how rare is and. If it is not so rare, it would be decreased in the order of importance in layman term. So yeah, then we come, so these were the very naive approach to convert the data into a numerical based form. Now we move towards a more intuitive, more semantically grasping approaches. Word embedding models were a key breakthrough in NLP. So they tried to learn the representation for text where the words that have same meaning have a similar representation in word space. So walking is associated with walked, swam is associated with swimming, king and queen are associated, man and women are associated in this kind of a sense, where each country is then associated to its capital, because so this is the word space. A word space can be n-dimensional, and these are the Turkey represents a vector that has been mapped into the word space. So Turkey and Ankara would be two vectors which are lying close because they have a relationship with each other. So yeah, word to vec is the classic most used model if you are starting into NLP. you will be using word2vec too frequently. You will find it in every single tutorial that has been uploaded over the internet. There are others. I personally love using fast text because you can train it very easily. Then there is Glove was introduced by Stanford. Word2vec was introduced by Google in 2013. So what was the whole approach about? So word2vec was basically, it was created to embed words from a text corpus. So yeah, I have written here, Thomas Mikolov invented it or developed it. Yeah, developed it would be better. So why was he working on word2vec? So he wanted to make the neural network based training of the embedding more efficient. So when you're inputting the vectors into a neural network, and you cannot rely so much on the naive approach of frequency based vectors. So you need word vectors which utilize the whole sense of semantic of the text. So word2vec was introduced to counterattack the whole loss of semantic nature of the text data. So now if you have a sentence, the word2vec embedding can make sense of the sentence, how vectors is associated with work. So yeah, I have given an example here. So if you have two different analogies, you have king and man. So if you remove man from king, you will get if you remove man from king, and if you're removing queen from women, you're capturing the analogy that king is to queen as man is to women. So now the models have started making sense. They are not just naive frequency based approaches, they are actually understanding the sense behind a sentence like we humans do, not as efficient, but yes, a little initial intuitive understanding is now established. So there were two different learning models that were introduced to be a part of word2vec. I'm not going to go in great depth about these models because then it won't be an introductory session. The two models were continuous Baggerford Seabow model and continuous Skipgram model. Seabow model learns by learns the embedding by predicting the current word based on its context. So what you're doing is you have been given a whole story that there's a fruit that is red in color, there's a fruit that is sweet, and you're predicting apple. That is how Seabow works. And the continuous skipgram model would learn by it has been given apple, now it would produce apple is red in color, apple is a fruit, apple is sweet, like that. So that's about word2vec. So what are the different tasks involved in NLP? I'm assuming that all of the audience has basic understanding of machine learning models or deep learning models. So I'm not going to go in great depth about a machine learning model or how does a deep learning model works. We are rather going to focus on the whole idea of using NLP with machine learning and deep learning approaches. So what are the different tasks involved? Okay, so now we are going to switch to a GitHub repository that I created when I was preparing for my interviews. So when we had the lockdown period starting, we were all suddenly focusing more on project-based learning, and I realized that just knowing the theory isn't the perfect path to getting a job. We need to have hands-on experience with a lot of projects. So I created a Telegram group where there were 100 plus members, and we carried out a project every week. So these are the basic projects that we covered: text classification, named entity recognition, text summarization, image caption generation, document similarity, and question answering. If you go on one particular link, you'll have the task, you'll have the data sets that were very famous and heavily used for that task, and then you'll have a list of tutorials available which you can refer or which you can try implementing. So yes, this is how it works. So text classification is just a very basic idea where you have been given a list of text and you're trying to put it into different categories. For example, BBC full text document classification, this one was what I used for my task. It will have 5 labels: sports, entertainment, and things like that. And now you have to train a model and you have to classify it into one of those categories. You can use embeddings to capture the text into vectors, and then you can use any kind of model. You can use a basic classifier from sklearn library, or you can use a basic multi-layer perceptron, or you can use a higher level LSTM based models, LSTMs and RNNs, or anything that you would like. Similarly, named entity recognition, we covered it. So yeah, so what you're trying to do here is that named entities are phrases that contain the names of person, organization, location. So basically, you remember learning about the whole idea of this is a proper noun, this is a common noun. So now you have a text and you have to pick up words, and you have to classify if it is a common noun or if it is a proper noun, or what exactly, what part of speech is it, is it an adjective, and so on. So this was about it. Then the third week of task, we did text summarization. So text summarization is really, really important these days. There are two types of text summarizations. One is extractive summarization, where what you're trying to do is you're not changing the content of the text. You're just picking up what you think is important, and then you're trying to generate a summary. So a 100-word text is now shortened to a 40-word text, but the content is same as the parent text. In abstractive summarization, you change the content. So you're not just picking out important sentences. Now you're trying to understand what is the whole paragraph about, and you're reframing all of the text data again into a smaller, more contained summary. So this is very important when you have long form documents. Say you have a 200 pages of a book, or you have a patent are long form data, they are like a few pages long, and then you need to create a vector of that whole data, but you cannot do it. So an idea would be to generate a summary of all that data, and now this summary is so small, and thus it can be embedded into a vector. So the other one was image caption generation. So you have an image image of an apple, and your model is predicting that this apple is red in color. So it is generating the textual description of the input image. So this is kind of on a conjecture of image and NLP based task. The other one is document similarity. Again, more than anything else, document similarity is one task I have repeatedly performed in when I was dealing with industry based tasks. So what is document similarity? You're just trying to map how similar two documents are. How is document similarity so important? Say you're performing a semantic search. You have a document, and now you want to find 10 most relevant document to this one document. So what you can do is you can perform a document similarity of this one document and these 10 documents, and now you can rank which one is most similar, which one is least similar. So this was one of the most important projects that I think helped me in getting a job later on in life. So I would definitely recommend you to try at least this project. So on LinkedIn, we are searching. I get DMs like, what would be a good project? So these 6 projects you must do and add it to your resume. So question answering systems have their own whole theory idea. So there's one very famous data set of Quora question answers. I use that. So you can also try using Q&A, but I would recommend you to understand the whole idea of question answering system first. There's a very good video lecture in the series 224N by Stanford. I'm going to mention all the resources that I've used for NLP later in the talk. So yeah, this was all about the projects which you can perform and which you can add to your resume. These are the 6 most important NLP tasks that I feel are relevant. There might be others as well. I remember doing a project on text generation using LSTM. So in that, you are trying to predict the next character of what you are typing, just like your Google Gboard works. So that could also be an interesting project idea. Let's get back to the presentation. So what else? So let us now talk what are the essential skills for a career in NLP. When we are dealing with a small project, we don't have that level of data which we are dealing with at an industrial level. So I would suggest you to master pandas. In all my job interviews, I was asked to share my screen and code in pandas, group by, merge, pivot table kind of a thing. It is very important that you are a pandas pro, and try watching YouTube tutorials, try handling lots of amount of data using pandas, try merging two different data frames into one, and try grouping on the, like, there's a dot group by function in pandas. I would suggest you to have a great command on that, because I lacked that and I have felt I have been penalized for the same. So master pandas. Next one would be, yes, so yeah, this meme is one of my favorite ones. I had a problem, so I used regular expressions, and now I have two problems. So I would suggest you not to underestimate the power of regex. Regex is one part that whenever we are going through any Python tutorial and then we have regex, we tend to skip it, because it is a bit, it is a language of its own. I cannot say it is just a library or just a tool. Regex is a language. So I would really suggest you to try understanding regex. I'll be mentioning the resources that I've used to understand regex at the end of the workshop. But do not ignore regex. If you want a career in NLP, you will be using regex, and not always you can rely on Stack Overflow for help. There are cases available, but you need basic understanding to manipulate those general cases for your own benefit. So yes, regex. Third thing would be, try everything rather than keeping your knowledge limited to theory. So what I have seen in general, so in just I have not been doing my full-time job for too long, but I had an opportunity to interview interns, and the bad part was that people know theoretically everything, but they are scared to try, or they don't want to invest time into trying. If you're putting a notebook in your resume, if you're putting a link to a notebook in your resume, and the interviewer is opening the notebook, and you're not able to answer why you have used a certain function, why you have used a certain pre-processing, that is not a good impression. So first, try to understand your data, understand what is unique to your data, what pre-processing is uniquely suitable for your data, and then apply it. Deal with data yourself. Yes, we all rely on code snippets from here and there, but it would be a good idea to try typing at least that code by yourself instead of just copy pasting, because when you're asked to share your screen and code and you don't remember the syntax to import stop words from NLTK, that could be embarrassing. So try. Project based learning is my emphasis, and it has always been my emphasis since I realized that just watching video lectures, making beautiful notes is not the end of your career or your expeditions in NLP. You need to try lots of projects. If you're doing lots of projects, you will have a lot to talk about in the interviews. So yeah, that was my tip. Yeah, so what's bonus? Just this, my list of resources. Regex is core shaffer. Like, this YouTube channel I've referred for almost everything, and the regex tutorials from this channel are total lifesavers. I have just seen one lecture series for CS224, that was CS224N by Stanford, and there are multiple resources available. The Coursera natural language processing specialization is also great, but if you're a beginner, I would strictly suggest you to follow this one. If even if you don't understand initially, there were times when I was watching the lecture and I could not grasp all the concepts as they were flowing. You just have to be patient, finish the lecture, you get a general intuition once you're done with the lecture, and then you rewatch it again, and then you'll be able to understand it better. Like, you study by layers. First is a general intuition, then is more specific things. Then there's this guy called Sendex, complete lifesaver if there's anything about Python data structure, Python multi-processing, multi-threading stuff. I watched the pandas tutorials from this place. So what else? Okay, so because there were so many questions on LinkedIn, so now I'm going to compile interview questions that I'll be posting next week on GitHub. So that's it. These are the references I used, and if you want, we can connect here. So I am open to questions now. You can ask NLP related questions, project related questions, or interview related questions. Thank you.
So guys, if you have any questions, please feel free to ask Shambhavi. You can drop them in the chat box.
Mm-hmm. Okay. Okay, so there was at 617, which ML library do you use? I use a lot of them. There are some particular libraries which help. Okay, I'll stop sharing my screen. That would be better, yes. Uh, yeah, great. So I use NLTK a lot. That is your go-to thing. Apart from that, mostly I'm using Keras and TensorFlow. I do not use PyTorch for NLP stuff. Okay. Can you tell us about your interview experience and how you got a data science job as a fresher? Okay, so this is definitely going to be my favorite question because so if my friends are watching this, we used to have so many discussions if it is a good idea to study data structure and algorithms, or should we focus on the machine learning part? How are we supposed to going to get a job? I remember a friend even told me it is not a good idea. Okay, so I remember a friend told me it is not a good idea to focus so much on just data science jobs. There's such a shortage of data science jobs in industry. There's so much input. No, if you're good at what you're doing, if you know what you're doing, people will hire you. And I just gave 3 interviews and I cracked all 3 of them. I took this one because I was getting an early full-time opportunity even before I graduated. But what I would say is do projects. What were my plus points? I did a lot of projects. So even so the first round is always screening your resume. So when people are screening your resumes, they go through your projects. And if you can talk about your projects very confidently, then you can make it. You can make a good impression if you, because in your projects you can reflect on different kind of experiences. In one of the projects you can use LSTM, in the other one you can use LSTM plus attention, or you can use encoder decoder based architecture. You can use GANs. So you can put every little thing, and that would give you a different, different kind of a flair. Like your resume can be spicy. So do it and just write things that you actually deliver. Do not exaggerate stuff. It is really bad if you have put a project there and you don't know anything about it and you're blabbering about stuff. No, don't do it. In interviews, if you don't know anything, just be very honest that I don't know. No, I never read it. I don't know. That's new. And the interviewer will explain it to you. That's the best part. So my interview experiences were all good in data science industry. Most of people are very helpful. If you are genuine and if you tell them you don't know, they will even answer your questions before the interview ends. Getting a job as a fresher, there can be 2 ways: do internships and do projects. How to get internship? Again, this is the whole cycle that we are a fresher. How to get internship? The first internship I did was a research internship. The second one I did was unpaid, and the third one was finally paid. So do not shy away. If the internship is unpaid but the things that you're learning have great value, or they will add great value to your resume, do not avoid just because it is unpaid and because there's LinkedIn posts that say that don't do unpaid internships. Most of the times there's a trade-off. If your supervisor or if your mentor is really good, go for it, take an unpaid internship. Yeah. So next one. Okay. Prachi asks, how should I start with ML being in first year? Okay, if you are in first year, you've got a lot of time. I started with machine learning when I finished my second year in July, when third year had already begun. And if I can do so much in just 2 years, you can do much more. So how to start? Do not jump on resources. Like you started one thing, you don't finish it, you jump on second thing. Don't do it. Pick one thing and finish it till the end. If there's one thing I would like to suggest you, would definitely be Andrew Ng's machine learning course. Why? Because it provides you with the mathematical aspect of machine learning in proper amount. Like you get a very good exposure to the maths of machine learning. So I would suggest, there's a book called you can search it, it is called MML, and MML is the book on your basics of maths that are going to be used in machine learning. You can try reading that book. It has basics of algebra, statistics, and then you can simultaneously try following the tutorial by Andrew Ng. That would be good stuff for almost 3 months. Then you can try exploring computer vision, NLP. I guess I have written a long blog post about this, how to start with ML. You can find it on my website, and shameless promotion, but it would be too long to cover in the answer. Okay, next one. How regex can be as I said, Core Shaffer is the best place, and there are a few tutorials by Sendex also on regex, so you can try following them. And what you can do is Twitter data or any data which has lots of hashtags, numbers, everything mixed, use it and practice it. Core Shaffer will give you tutorials, try to follow along with them, and you're done. That is just the amount of regex you will need in life. Other things can always be covered from Stack Overflow. Okay, next one. All right. So this one is funny. There's just one hackathon that I have appeared as a participant, and that was Smart India Hackathon in 2019. We won the hackathon, so that was the kickstart of my tech journey. How was the experience? That experience actually made me realize that I was made for the tech stuff. The whole kick that you have to start a project from scratch and finish it by a particular duration, and then there are mentors who kept telling you to add some features. So all of that rush that we had during Smart India Hackathon was the best part. So that was my only hackathon experience. After that, I have mentored the last edition of HackBMU 3.0, which was offline and which was a great experience. And apart from that, I've mentored over 6 hackathons so far. So yeah. Okay. I don't like maths. That means AI, ML, and data science is not for me. So you don't like maths in general, or you don't just like a part of math? It is not like AI, ML is a place where you'll be solving just indefinite or definite integral problems. No, it is more like you need to have an intuition. If we are talking about a convex loss curve, then you need to have an intuition how are you going to back propagate through the gradient. In fact, at the beginner's level, you don't need so much of maths. You just need to know that if you're back propagating, then there are differential equation, there are partial derivatives involved, and you should be able to understand it. But trust me, AIML part, if you get into it the right way, it is so interesting that you will try to understand maths. You will start getting the intuition of maths. But if you are strict, no, I don't want to deal with math part, I guess you can try other fields as well. You just don't have to force yourself to get into AIML. Yes, that's it. Okay.
So I guess, oh, okay, we have one more question.
Okay. Can I switch to ML after web dev, or should I focus on only one field? Depends on why you want to switch to ML. If you're just running to ML because it is hot topic, then I would tell you to master web dev. There are a lot more opportunities more opportunities in web development as compared to ML. In my own like the place where I work, there are 20 people in the development team, and we are just 2 data scientists. So I would say that if you're not really interested about ML, stick to web dev. It is a good field. It pays you well. You can take up freelance projects. You can express your creativity and everything. But if you want to switch to ML, it would be great. You will always have an option of switching back to web development. You'll have a multiple skill set of web dev plus ML. So if you're interested, you can switch. Or if you just want to jump in because it's hot, then you should focus on just one field. Like, why did you start with ML instead of software? A good question. A very good question. Okay, so um, this is just a small story because you asked me, so now you have to hear the story. I'm sorry. Uh, how I came into ML, I did not come into ML. I was more or less thrown into it. So I went for a research internship to a professor in JNU, and I went there with my skill set of HTML, CSS, little bit of JavaScript. I had taken a Udemy course on web development actually. I didn't think I'll ever learn Python or come into machine learning. I was happy with web development course on Udemy. So now the professor asks me after spending 1 week over there that how much time do you think you need to learn Python? So I said, I guess 1 week should be enough. I know basics of C. So I spent 1 week learning Python. And after that, he gave me a project where I had to work on removing noise from an audio. So I like, then there was a PhD scholar with whom I was working. She gave me whole flow chart, like you need to apply this filter. There was a Kalman filter. You need to convert the speech signal into something else using fast Fourier transform. Lots of steps she gave me. I performed them after 3 months. It was a struggle to do it, honestly. So after 3 months, I was done with the internship with a certificate. And then I was talking to a friend of mine, like more like a cousin. So he told me that, do you know you were working on AI? So I'm like, no, not really. So then he started telling me that NLP has two parts: there's speech and there's text, and you were working on speech, and that was NLP, that's all a part of AI. So after doing the project, now I started watching the whole Andrew NG lecture series. I finished it in 1.5 months, and I'm watching NLP tutorials, then I'm applying for other internships. So that is how I started with ML. I didn't have a chance to start with software development. I wanted to start with software development initially. I guess we are done now. Any more questions? Okay. So I guess since there are no questions, Akansha, I would like to end on the note that uh, despite what all flood of resources you see, okay, there's another question. I'll just finish it. Despite the flood of resources that you see all over LinkedIn, and there are courses being projected everywhere, choose one resource, choose a standard resource. Stanford, University of Waterloo, every good university has their courses offered on YouTube. Stick to them, try doing their assignments. You'll find link to the website in the description of YouTube videos. Try doing their assignments, and uh, just follow one structural approach instead of doing small courses which just give you an intuitive understanding. Yeah. So there are a lot of questions. Yeah. Do you think ML is overrated in the tech community? So if you would have asked me this question 2 days ago, I would have said yes. But what happened was, yesterday I was on a call with a man, with my manager, the place where I used to work with earlier, and I asked him that why are suddenly, like, in this particular domain, I don't want to name that domain, say health, why now every startup in health domain wants to get into AI even when it is not needed. So he said that is because clients are asking us for that. People want AI because AI is the new thing. So if people are asking for AI, we have to provide AI. So ML is overrated or not, I cannot comment. But ML is being asked for, and thus people are providing it. Hence the whole hype. There are a lot of people in ML. I see a lot of youth, like second year, third year students in ML, trying to start into it, trying to copy projects from blogs. They are not learning it the right way, is my concern. ML being overrated, I believe AI is the future. AI will be everywhere after a few years. So you cannot judge it as an overrated field. It is an omnipresent field, rather. Yeah. Okay. Good question. So, yeah, I have been into research for quite some time now. What are the most important aspects in choosing research projects and teammates? I'll answer them in two different ways. For choosing research projects, there can be two approaches. One, you are targeting the hot topic and you're trying to advance the last progress that was being made. It is tough, it is time consuming, and you need to be updated with all of the SOTA, state of the art architecture, that is being going around. So make sure that if you're choosing one particular domain for research, just because it is hot, you should be motivated enough, because if it is hot, then everyone will be working on that, and you have to be creative enough to beat that, or at least do significant contribution to that hot topic. How I choose the research project is, I search why should I work on that project in the first place. Like there should be one single motivation that can be personal motivation, like because if I'm working in this domain and this domain is so less explored, so it is a good chance for me to do better in this domain. That can also be the motivation, or the motivation can be contribution to a social cause. Like I was working in a sign language based project, and my motivation was there was no solid architecture in Indian Sign Language, so I want to work in Indian Sign Language. But then I chose another project where I was working because there was so less research advancement in that project, in that domain. So it was a good idea to work in that domain, and also because the domain did not have so much work, so my work would be easily noticed. Important aspect in choosing teammates: motivated teammates. That is the only important aspect I think it is there. If your teammate is motivated enough, even if he or she is very busy with personal commitments, job and everything, they will find work to finish it. But if the teammate is attracted just thinking that you are going to do major part of the work, then you are getting trouble for yourself, not a teammate. No. So if the guy or girl is very motivated, team up, else do it alone. It is better to to focus all your effort into completion of the project rather than monitoring your teammate. So that is what I would suggest. Okay, great.
Okay, well, ladies and gentlemen, that wraps up a session. So, on
Thank you so much.
behalf of thank you, Ms. Shambhavi. On behalf of HackBMU 4.0 organizing team, I thank Shambhavi for taking out time from her extremely busy schedule to join us here. Now, we would like to express our gratitude towards all our sponsors who are making all this possible. HackBMU 4.0 is brought to you by our platinum sponsors, Dayfolio and Coding Ninjas, our gold sponsors, Matic, Fortis, and Tezos, our workshop and coding partners, CodeChef and an academy. Partners, JetBrains, Sketch, Rosenfeld, Balsamic, No Starch Press, Cascade, Sashido, Echo AR, One Password, Exure, Egghead.io, The Codex, Codesylums, Testmail, Bodylog.in, Give My Certificate, and InMovido. Our digital learning partners, Board Infinity, and our media partners, Cryptopolitan and ED Times. Thank you, everyone. We appreciate you being here. Don't forget to fill the feedback form for the session to receive your certificates. The link for the same is in the chat box. Thank you. Thank you, everyone.